For efficient combustion, a modern diesel engine requires several thousand times as much air as it does fuel. Under normal operating conditions, to burn 1 gallon of fuel, you have to clean 15,000 gallons of air. Add a turbocharger to that engine, and air consumption requirements increase by 20% or more. A gasoline engine, however, requires substantially less air than a diesel engine. A typical gasoline engine will consume 8,000 to 12,000 gallons of air to 1 gallon of gasoline. Let's take a look at exactly how a typical diesel air induction system works. The air induction system is designed to pull in outside air and should be located in an area that allows the least contamination. On this semi-tractor, the intake is located in a spot where exhaust flow, road grime, and splash will have minimum effect. The system of ducting, hoses, and reducers that connect the air intake with the air cleaner requires a different design on nearly every vehicle. The pathway design of a diesel air induction system is critical for two reasons. First, it must be large enough to carry the airflow required for efficient combustion. And second, its design must include provisions for removing airborne contaminants. The pathway design of a gasoline air induction system is the same as a diesel engine. First, it must be large enough to carry the airflow required for efficient combustion. And second, its design must include provisions for removing airborne contaminants. Proper air filtration is important because a small amount of dirt can cause a tremendous amount of engine damage. Tests have shown that you can wipe out turbochargers, score pistons and cylinder walls, damage bearings, and ultimately destroy an entire engine with less than 1 cup of dirt. That's why proper air filtration is critical. But how does it work? The real muscle in any air filter is the media, or filter paper. A closer look at the media shows a wide variety of different sizes and shapes of natural cellulose fibers. These fibers create a tortuous path through which incoming air must find its way. This is relatively easy for the air itself because its molecules, which have an elastic substance, can bend at will to move through the cellulose web. Not so for the dirt which is carried in the airborne stream. From the time the first particle enters the filter, it must change direction again and again as it tries to work its way through. The path is so difficult that the dirt will become lodged and held in place among the fibers. But that's just the first particle. What about the next several billion that will collect here during the filter's life cycle? As dirt particles begin to cake up inside and on the surface of the media, it becomes tougher for other particles to get through. While this causes a gradual increase in air restriction, it also results in increased efficiency. When enough dirt has accumulated to cause significant airflow restriction, engine performance is reduced. But until you reach that point, you may be throwing away filters that look dirty but still have many hours of useful life left. We will discuss how to determine when it is the right time to change a filter in the Problems and Preventive Maintenance section.